Rate of change is our math tutorial today. Welcome back to my channel. Albert can walk 4 kilometers with the same time as Bernard can walk 5 kilometers. Albert takes 3 minutes more than it takes Bernard to walk a kilometer. What is the rate of Albert in kilometer per hour? Now, how to solve this one? If we let VA as the rate for Albert, the velocity for Albert, and VB is the velocity for Bernard, it says here that they're walking at the same time, but Albert can walk 4 kilometers and Bernard 5 kilometers. That means the distance for Albert is 4 kilometers and Bernard is 5 kilometers. Now, to solve this one, we have to use the formula of velocity, which is equal to the distance over the time, or time is equal to distance over the velocity. Now here, because they have the same time walking together, so TA is equal to TB. Now substituting this, the formula of time, which is equal to the distance over the velocity, is equal to dB over the velocity v. Now, for Albert, he got how much? 4 kilometer over the VE and dB, which is equal to 5 kilometer over BB. Yes. So therefore, if we have to cross multiply this one, we'll have this 4 kilometer BB is equal to 5 kilometer VA. BB therefore is equal to 1.25 VA. Now we got equation 1. We have equation 1, VB is equal to 1.25 VA. Then another one, from this second sentence, Albert takes 3 minutes more than it takes Bernard. So Albert will take 8 minutes more than it takes to walk for a kilometer. So at a distance of 1 kilometer, Albert can takes 3 minutes more than it takes Bernard. That means Albert at 1 kilometer, which is at 1 kilometer, Albert is can take 3 minutes more than Bernard. So the time is equal to 3 minutes more and divided by 60 because we need to be in per hour. We're looking here for kilometer per hour now. Our distance is in kilometer, so we have to convert 3 minutes to hours, so we have to divide it by 60. Therefore, substituting the value of BB, which is equal to 1.258, so 1 over VA is equal to 1 over the value of BB from the equation 1, which is equal to 1.25 VA plus, see, we can reduce this one to lowest number, which we can divide this by 3, divided by 3, this will become 1 over 20. Therefore, VE, simplifying all this one, VE is equal to 4 kilometer per hour. And VB, of course, we have already VA. Therefore, VB is equal to 1.25 times 4, which is equal to 5 kilometer per hour. That is the value of VB. Now, what is the rate of Albert in kilometer per hour? We are looking only for Albert. So the correct answer is 4 kilometer per hour. Second question. A man drives at a rate of 25 km per hour towards the foot of an 8-meter tall monument. At what rate is he approaching the top when he is 42 meters from the foot of the monument? Now here, I wrote the solution. And here is the rough sketch of the monument and the car approaching toward the monument. Now, here I designate the distance from the car, where the car is, to the base of the monument, which is equal to x. And it's given to be 42, and this height of the monument is equal to h, which is equal to 8 meters, which is given also. So now, because this is approaching towards the top, so we have the incline, so we have to write from this one, we have to connect the line from this one to the top of the monument, and we will designate it as S. Now, what is given here is the rate of 25 kilometers per hour. Rate means we're talking about here the derivative. We have to differentiate. So, at a rate, that means kilometer per hour. So this is kilometer per hour. That means kilometer, which is the distance, and per hour, which is the time. That means this is dx over dt. So this is dx over dt given to be 25 km per hour towards the foot of an 8-meter tall monument. Now what is required here is then, at what rate is he approaching towards the top? So towards the top, that means because we're concerned about the ds dt, the rate of change of the distance from here going up, so we designate it as ds of dt, the rate of change of the s with its respect to time. So we're looking for ds dt. Now here, from this diagram, we can solve s using, so we make this one a triangle here. We separate here. This is the s, this is the height, and this is the x, which is this one. So this is triangle, this one. So from this diagram, you will see that s squared, using the Pythagorean theorem, s squared is equal to x squared plus h squared. This is the formula. Now, simplifying this one, s therefore is equal to square root of, this is square root of x squared plus h squared, which is equal to, this can be written also as x squared plus h squared raised to the power 1/2. Now, because we are looking for the rate of change of the s with respect to the time, the distance going up, ds dt, so we have to differentiate ds dt. So ds dt therefore is equal to, the derivative of ds dt is equal to 1/2, using the power rule, 1/2 times this one, x squared plus h squared raised to, because this one, the power here, and this is, which, for example, this is in, which is equal to 1/2, so it will be minus 1. So 1/2 minus 1 will be minus 1/2. So it will be 1/2 x squared plus h squared raised to the power negative 1/2. The exponent is negative 1/2 times the derivative of the x, which is equal to 2x, and this one because we're not, what we call this, we're not concerned about the height. The height is the same. So, the derivative of 2x, which is x squared, which is 2x, and then times the power, which is equal to 2 minus 1, which is equal to 1. 2x raised to the power 1, or 2x, times dx dt. Therefore, dx dt is equal to, simplifying all this one, is equal to x divided by the square root of x squared plus h squared times dx dt. Now, substituting the values of x, because we have x, which is 42, dx dt, which is equal to 25 km per hour, or change it to meter per second, which is 6.944 meter per second. So here, the dx dt will substitute divided by the square root of x is equal to 42 squared plus h, which is equal to 8 squared. Simplifying this one will result to dx dt is equal to 6.822 meter per second, or if you want it in kilometer per hour, it is equal to 24.558.
Sorry, it's DJ.